welcome back to Everything Mathematics, and today we're going to bring our topic of surds to an end by just doing various questions, some disguised, some straightforward, and some might just be able to probably expound our thinking a little beyond, the ordinary. Not a little beyond, quite a lot beyond. So let's start with several examples. I only have 4, so as soon as this 4 is finished, that should be the end of today's video. So here we have, first example, we ask us to simplify root 8 plus root 8. And off the bat, somebody might see that, okay, root 8 and root 8 is the same. And it's understood perhaps that there's a 1 in front of each one here. There's a 1 there and a 1 there. So some persons might believe, well, this will just come down to as simple as just adding root 8 and giving us 2 root 8. But this is not quite the answer because you see, root 8 can still be further simplified. So when we do that, for instance, that's the best way to start. So we are applying rule 1 here before we actually simplify or add these two quote unquote roots. Root 8 can be equally written as 4 times 2. You see, there's a perfect square inside of 8, so that should help us to solve it even better or give us a more accurate response. Plus, we have the same thing because it's the same 8, so we have 4 times 2. This eventually, of course, is the same as root 2 times root 4, times root 2, plus, same thing on the other side, root 4 plus root 2. When we simplify this, the square root of 4 is 2. So this is 2 root 2 plus, again, 2 root 2. And when we solve this now, notice that we have a common square root, so we could add the coefficient. This will ultimately give us a response of 4 root 2, which is definitely not equal to 2 root 8. So yes, you have to be very careful with a question like this. It might look straightforward, but look at the disguise behind it. So in a case like this, you always have to be on the lookout to see if the two rationals or the two roots can be further broken down. And if it could, then do. If it cannot, then it's okay to add them just like that. For example, let me say we had a scenario where you had something like, let's say, root 7 plus root 7. In a case like this, 7 is a prime number. So there's only 2 factors that could go into 7, itself and 1. So in a case like this, it would have been perfectly fine to end up with a result as 2 root 7. Because remember, this is just as if we would have had x plus x. So the answer is simply 2x, we just add them. But this would have worked for 7 because there's no factor that could break down 7. But the same is not true for 8, right? So be very cautious there. That would have been an easy disguise to come up with there, right? Let's try the second example. So for example, number 2, we have the root of 75 minus the root of 27. And this one is a little more explicit because of course you would not go out straight up. Well, no, let me be careful. Some persons, for all I know, they might see this and they might think, okay, let's subtract 75 from 27 and you get your ting. So some persons probably would see it like that, but no, you have to be careful. Sometimes that's not how it works. So here, of course, you try to find a perfect square or perfect number, a number that will give a perfect square inside of 75 and 27. Unfortunately, I could easily see the one with 75, that's like 75 cents. And I know that 3/4 could give you 75 cents. So that is 25 multiplied by 3 minus 27. Well, I know for the 27, you have 9 multiplied by 3. And again, we just separate them. So that's root 25 multiplied by root 3 minus root 9 multiplied by root 3. And the square root of 25, that will be 5. So that's 5 root 3 minus the square root of 9 is 3 root 3. And this one worked out pretty nice again. The roots, what's under the roots are the same. So according to rule 4, I think, you keep what's under the root and you compute what's outside, or what we could call the coefficient. So here we will end up with a result of 2 root 3. How did I get 2, you may ask? That's 5 minus 3. Remember, we operate that. And what's under the square root stays the same. And that's how we end up with such a response. What we got for the first one, that we got the same response, that we got 2 root 3. Right, so that takes us to example number 2. Moving on swiftly today, it seems. So let's try a third example and see what we get. So for the third one, we have root 3 plus root 6, and all that's been divided by root 3. Good. And yes, in a case like this, we have to rationalize because we have a denominator of our root. And this one is pretty simple. Since we only have 1 at the bottom, we just multiply by that same one. So we multiply by root 3, top and bottom. And that should solve that problem, no worries. So here we have root 3 times this, then 5 times 6 times that. Oh, where my arrow gone? Anyway, so that's that. So let's see if we could simplify that. So at the top, root 3 times root 3, that will just give us 3. Plus, we have root 6 times root 3, and that will just give us root 18. And that's divided by just 3. So this could be our final answer, or if you so desire, you could have 3 over 3 plus root 18 over 3, which will work out eventually to be 1 plus root 18 over 3. Good. So that's our final answer here. And we could have done that from day 1 also, from step 1, because notice, I don't know if you saw it, I didn't want to mention it there, but notice if you have root 3 plus root 6, all over root 3. This is actually the same as root 3 over root 3 plus root 6 over root 3. This root 3 would have cancelled this root 3 to give us 1. But notice we would have still had to rationalize this side because we still have a square root at the bottom, and we would end up with the root 18 over 3 when we would have divided and multiplied that root 18 over 3 here. So that's just food for thought. Food for thought. It would not have saved you the hassle of rationalizing, but perhaps it would have made your life a lot easier in the event that maybe you couldn't see the 3 times that, the 6 times this, and So that's just a thought. And the last question I have here for today, we have 2 root 5 minus 15 root 3, all divided by root 5. And this one again is kind of straightforward. Because to be honest, I just found different questions randomly online. I just picked them up. So yeah, but this one again, since we have one denominator, you simply multiply by that denominator. No need to find a reciprocal or what's not. But let's see, maybe this might give us something interesting. So let's do the denominator first, since it's very straightforward. Root 5 times root 5, that will just give us 5 at the bottom. The top looks a little interesting. So we have 2 times this, and then we have minus 15 times that. So notice that for 2 root 5 times 5, the root 5 times the root 5 will just give us 5. As a result, we'll have 5 times 2, which will give us 10. So that's what we get at the top here. So this will be 10 minus 15 root 3, negative 15 root 3 times 5. Well, this 5 and this root 3 will be multiplied by each other, and the outside, the coefficient remain the same. So that will be 15 root 15. And yep, I think that is as far as we could go. Nope. This could actually simplify further. So this could actually go down to be 10 over 5 minus 15 root 5 over 5. And here we could break down the 5. So 5 could go into itself once, and 5 could go into 10 twice. 5 could go into itself once, and 5 could go into 15 thrice. Thrice is a what? 3 times. So that will leave us with a final answer of 2 minus 3 root 5. Oh, that actually worked out interesting. I didn't see that one coming. So yes, this here would actually be our final answer. 2 minus 3 root 5. So yep, that will bring us to the end of today. Of course, if there's any question that you would like for me to attempt, I will gladly do that. Just feel free to put it in the comment section below or contact me by any means necessary. And I'll be more than happy to assist in solving any such problem or question that you might have. So until the next time, tomorrow we're going to start our new series on logarithms. So until then, you take care.